Hello and good afternoon, everyone, and welcome. My name is Alin Blidisel, and I'm a senior technical lead at Pacific AI. And together with Alex Thomas, our principal senior data scientist, we will present the continuous testing and monitoring of large language models that we built inside Pacific AI to evaluate large language models. So, what we will cover today as an agenda, we will have the Pacific AI evaluation platform, what it is, why it matters, and how it helps to evaluate LLMs continuously and at scale. Another important point here is the Pacific AI platform architecture and build overview. Let's say a clear walkthrough of the platform, the components, integration, and operational patterns, so everyone can understand how it was built and how it can be adapted or integrated with different APIs. And the back end of it, like the Pacific AI methodology, how to compute stuff, and using the judge LLM for specific cases. Okay, so why it matters and why LLM was needed, like to have an evaluation plan, is like LLMs are changing fast and are somehow like fail in ways traditional models don't. So continuous testing and monitoring aren't optional right now. So they will be and will become essential for safe, reliable, and compliant deployments. And over the next 20 minutes, we will try to cover the key features and to explain the concepts and how Pacific AI has addressed common challenges, data drift, evaluation coverage, performance regressions, observability, and incident responses. So we will try to map these ideas to concrete architecture and implementations. So a quick note on the outcomes of this webinar would be like, by the end of this webinar, we will have like a practical understanding how to set up continuous evaluation and for the pipelines of our LLMs, what metrics to monitor and what confidence and score we will get by different LLM providers, and how evaluation, monitoring, and stuff can be integrated. Okay, and let's get started with the key features. So the key features as we have here is like the ongoing evaluation that we need to introduce into our system. So we must to validate models regularly in realistic settings, so not just at launch. So that means that scheduled re-evaluations against recent clinical data, subgroup analysis to surface disparities, and also target stress tests for rare conditions. So we need to make sure that if a model comes up, we will test it like version 1, then we have version 2, and we can monitor and observe exactly what changes were done and what are the changes on the overall score based on the conditions. Also, the aim for metrics that are disaggregated and by clinical decisions, or to detect different rare conditions that can alter from one evaluation to another. Then the real world monitoring. In them we have the continuous telemetry from production, that it's essential in a way, and also to instrument the model outputs, clinician feedback, and downstream outcomes. So these are like monitoring the distribution of the records that were sent against evaluation, and see exactly what information we have retrieved back, like prediction of confidence and also override of the rates. So how this can be integrated is like by configuring alerts for clinically meaningful deviations, so operations and clinical teams can investigate before harm occur in their system. So data can be validated against different LLMs by different providers, and expose these harm conditions. External collaboration, it's like to bring independent expertise into the loop, use external auditors, clinical subject matter experts, and patient advocates for periodic audits and fairness of for reviews. So share the de-identify evidence packages under governance frameworks to validate the results and also to try to build trust with regulators and users. And one of the most important, not the last one, is the adaptability. So how what process do we need to build to make sure that the models needs to require update and also to control the data that come into the system, because there will be like public data sets plus private data sets that will be used in the backend to maintain regulation and also societal expectation. So what we need to do is define clear retraining triggers, validation gates, and change management workflows. And what that platform, the evaluation platform, also will ensure is like versioning, approvals, and roadmap plans are in place, so updates improve safety and equity without introducing new risks. So as key takeaways for this, it's like this will combine rigorous periodic evaluation with continuous monitoring, external oversight, and an operationally mature update lifecycle. So let's move to the next slide and explain why this platform, it's a unified LLM evaluation, because this one will have like the possibility to enable CI/CD integration by, let's say, API driven. So this is like a faster and safer way of doing like releases and check against available LLMs, open LLMs or static LLMs that can be deployed in the system. Then very friendly like UI that for non-engineers to make sure that they can test and have like product compliance and red team to run tests and then also to view results without doing any coding. So by simple UI, and I will show that into a demo later during that webinar. What we have here as expectation is like this will reduce risk and speed the iteration of the test by having like visibility on previous run, current, and whatever, and be able to do like comparison between the runs. And as business and operational outcomes, it has like end-to-end governance, centralized dashboards to expose metrics with accuracy, safety, and latency. Then logs, audit logs that support compliance, post incidents analysis, and regulatory reporting. So this will also have like support and also customer value for our stakeholders, and this will map the outcomes of specific LLM evaluations by Pacific AI. So this is somehow like the capability of the platform and architectural components that we will try to walk through. Okay, so to unlock this comprehensive and customized evaluation, the Pacific AI connects with multiple external testing providers. So teams internally and also users that doesn't have like programming skills can run a wide range of tests across tailored categories and subcategories. So users pick the exact test and data sets they need, and each run uses dedicated relevant data sets for accurate results. The platform, in a way, performs end-to-end evaluations, checking safety, fairness, accuracy, and compliance. So teams can get reliable, actionable assessments and can collaborate seamlessly with partners. Okay. Let's move to the evaluation providers that we integrated in the Pacific AI Eval platform. And as we see here, we have like three major providers integrated. MedHelm, that it's a Stanford open source library for medical model testing that we collaborate, and we have integrated it because it was validated on real world clinical data, and it has like a clinical accuracy and utility. It's focusing on diagnostic relevance, guideline concordance, and also actionable clinical recommendations. So it's designed to assess whether model outputs are clinically appropriate and safe for care settings. So this is like the one of the provider, the MedHelm. Then LangTest, it's our own internal library that was dedicated. It's an open source library that can be used for testing LLMs. And this is somehow like taking care of evaluation suite for bias, robustness, and fairness. So LangTest runs demographic disaggregation, scenario-based, and also stress test. So for performance, this and also make sure that this diverse category and subcategory for different type of scenarios. And another important provider that was covered, it's the red teaming that was completely built into Pacific AI, and it's an adversarial safety service that executes text type probes and also try to identify medical red teaming across 50 plus categories and subcategories. And what red teaming identifies is like unsafe, undesirable, or non-compliant model behaviors, hallucination, policy violation, privacy exposures, and also it can be used with custom data sets and can evaluate based on custom data sets that we can address as an input into our evaluation platform. Okay, if we want to have like a clear understanding and a clear view of the AI evaluation platform, this is a clear picture of how things are integrated and how they are looking based on each independent provider. So this diagram maps in a way how Pacific AI evaluation platform integrates somehow like providers across layered evaluation capabilities. So at the bottom is the data and the test asset management, where dedicated data set and the de-identification and test definitions are residing. And basically the evaluation and the execution sits in the AI evaluation platform, where we have MedHelm, LangTest, and red teaming. So as the aggregation layer that we see here, it's like where we get the detections for aggregation of that collects results, metrics, and logs, normalizes the outputs that we get from LLMs and collect them into a nice way, exposed way for the UI. And together, this stack, it's delivering end-to-end evaluations that can cover clinical accuracy, acuity, and safety before using the AI models into a real development phase. Okay. What can we identify as key metrics in the evaluation platform, and what are the most important metrics that we get out of these evaluations are like and what is like the scope of all the evaluations are to get like metrics in terms of like accuracy, that it's like the scope of this one is like to measure factual correctness of medical responses, and they're somehow like and how they are applicable in the clinical workflows and medical decisions. Then the focus here on this is like how to make sure that the correct identification and the labeling of the conditions were made before running against the AI evaluation system. So all of this, like these metrics like performance, then robustness and bias, robustness, fairness and bias, and safety and ethics are all important metrics that can be obtained by using different type of categories and subcategories that are exposed into the AI eval platform. and will treat different conditions and will expose different scores and scenarios for each of these key metrics here. So in terms of performance, so we will have like precision, recall, F1, and also explanation of the quality. We'll have like clear understanding and clear dashboards, how to see exactly what has happened on the evaluation in the backend. And the most important focus on the performance is like task specific, like and explanation, and also completeness and justification that we have an evidence of what has happened on the evaluation plan. Okay, on the robustness and the stability of the system, that's where we will as an important scope. It's like everything is like scope. What is the scope? What is the focus of each of the metric, and also what value it brings. So in case of robustness, the focus is to response, variance, failure, modes, and atypical representation. Then resilience to adversarial or low resource inputs. And the value that this one brings is that it detects in a way unpredictable behavior in production, and informs like what should be like investigated, and what is the weakness of the used model. In terms of fairness and bias, this is to detect like performance across demographic and clinical subgroups, and also measure sensitivity to protect or to identify what was not done well. So this is like more or less the value that this will bring is like this will prevent unequal treatment, that will support regulatory compliance, and also this will preserve patient. This will preserve like bad results into using that LLM into the real world system. In terms of the safety and ethics, this is like as an important value that it will reduce patient harm, enables accountable remediation, will provide evidence for governance and regulatory reporting. So based on the evaluation plan and analyzing the results from the AI eval, user will be able to identify how the LLM has acted on the system. Okay, that's the key metrics, and I want to move to the next section. In them, I will expose the AI platform architecture and how it was built, and what are the components that were used. And in a way, we have like a major modular component that is taking care of the evaluation, and these are like Math, Helm, lang test, and red teaming that operates as a specialized engine that it's treating clinical validation, fairness, robustness testing, and also adversarial safety tests that are run in the backend. So then we have the integration layer that it's somehow like secure connect, that it's securing the connector to external providers. So everything is saved and stored into a secure manner in the system to avoid any exposure of the credentials or information that doesn't need to get outside. So all of this is saved into a secure mode on the environment. And there are API and SDK integrations for non-engineers that can expose like testing non-LLM endpoints and testing like a real API and converting into like an LLM endpoint into the AI eval application. Okay, then we have the data pipeline. That's how we use the data sets and what we are doing with the data sets. So the data sets that are used are curated, dedicated data sets per category and subcategory. So they are maintained, updated periodically to support each independent category and subcategory from the evaluation plan. And this one and ensures in a way the relevance and diversity in the testing plan. And model integration, each model, whatever model, external or internal model needs to be used, this can be stored, exposed, and saved into the application, and then be used in the testing plan automatically. So we have created an adapter that adapter takes care of the LLMs integration and will store each LLM into the platform and make it available for further usage. The orchestration and the control plan, where we are doing the test workflow management, and this is like a central orchestrator that schedules and executes multi-engine test plans, like pre-post, the deploy checks, parallel runs, and monitors the progress in real time, and enforcing something like rollback policies if something is not working well, like request per minute and and monitoring how tokens per minute to avoid any limitation and stuff, to make sure that nothing will fail. Okay, and as the last plan, we have the reporting and insights. So this is like an aggregation layer that normalizes all the results of the output of the LLMs and the unified metrics and the visual dashboard and the evidence that is exposed through the dashboards. So this is like provides like drill downs to see like model version, data set slide, and demo subgroups and test category to inform the user about the test results into a nice mode and nice way. Okay, and I will hand it off to Alex next for his part.
Thanks, Alin. Yeah, so I'm going to talk a bit about the methodology behind what we do at Pacific AI. An important thing to keep in mind is that if we're going to be doing testing of LLMs and LLM-based systems, we need to make sure these tests are meaningful, comprehensive, and we can adapt to different use cases. So what I mean by meaningful is that if you just do generic benchmark tests from some open data set, you can learn a little bit about your system, but you won't learn what you need to know about how your specific use case is working. So you need to be able to target it towards the use cases, the scenarios, the risks that you're facing. It also needs to be comprehensive. So you want to be able to test a wide variety of things. This is different than a lot of other AI or machine learning applications in the past. In the past, most systems like this had very targeted capabilities. So if you build a logistic regression model to test something, that model can really only do one thing. But LLMs have a really broad set of capabilities. It also needs to be adaptable. So if you are adding functionalities, you want to be able to easily add tests for that. And you also need to be able to test for things that maybe bad actors would want to do with your system that you want to stop them from doing. So we need all three of these aspects. Pacific AI supports meaningful tests. So we have a diverse taxonomy, and we have it covers different threats. It covers different use cases for healthcare LLMs and LLM systems. And the user can select which tests are relevant to them by the elements of this taxonomy. So you select different categories, the subcategories. You can test across different models and model versions. So you can compare a model to itself over time, or compare two different runs and see which one's doing better. And when you do monitoring and live testing, this is something that, at least in my experience, it seems like a lot of teams working with LLM systems are a bit lagging on. They sort of do some initial testing, and then they hope that that's okay. But anyone who's worked with software for a while knows you need to be constantly monitoring these sorts of live user-facing systems. So by being able to do these things, it allows you to make sure your tests are actually telling you that your system is reliable or has checked a problem. So this is how we support meaningful tests. Comprehensive testing, we do that by combining data sets from various sources. We work with Coalition for Health AI, CHAI. We work with them, and we work with one of their projects, MedHelm. We've actually incorporated it into Pacific AI, so you can access all the different data sets in MedHelm. We also incorporate data sets from current bleeding edge research, and we even build our own data sets. Because LLM testing is still somewhat of a new field, anyone who wants to do in-depth, serious, robust testing will likely need to be working on their own data sets. If not curating and modifying existing data sets, then maybe like we're doing, building them from scratch. And we're continuously expanding our collection of data sets. And finally, we do support adaptive testing. So there's a few different ways to do that. We allow users to configure their test suites by selecting categories and subcategories of test scenarios based off our taxonomy. And by incorporating MedHelm Lang Test, which is an open source project that we have that can do permutations and perturbations on a given set of data. And also another data set and tool that we built for red teaming. So these are this is one of the data sets that we're building, where we design these adversarial tests in order to check for compliance and safety. So building a test that might elicit a biased response or might elicit a dangerous response. And we also allow users to create their own tests. Now, these might not necessarily be in the taxonomy. You can label them as such, but if you have a very specific aspect of your use case, you can also test that in the platform. So we have different techniques that for evaluation. So you can create a data set that does exact match. You can create one that has an LLM as a judge. And you could also, and we're looking at adding more tests, more evaluation techniques in the future, including being able to supply specific prompts for your tests. So we're talking about these tests, but I think we need to take a step back and look at it from a higher level. When we're testing LLMs and LLM systems, there are 4 tiers. This is the way I like to think of it. I believe this is actually originally I may have read it in a Microsoft blog. But so there's tier 1, and that's testing the model directly. So I would say the vast majority of even LLM testing data sets out there are for tier 1. That they are expecting this is just a no context, singular call, singular response from an LLM. And that is useful, especially when you are developing the model, because you don't want to necessarily confuse the results with other augmentations in your system. However, if you're looking to test your system, you also want to test these other tiers. So tier 2 is testing with validation, e.g. guardrails. In my experience, I think at this point, the sort of guardrails has the meaning of it has broadened to basically cover all sorts of validations coming in and out of models, and this lets you see if any of the safety checks or any of the other post or pre-processing steps are affecting these metrics. And it's actually, I think, a good idea to sometimes think about testing your system at different tiers. So if you were developing guardrails, it probably makes sense to test tier 1 and then tier 2 to see what effect the guardrails are having. And then test 3 is the model with grounding and validation. So, for example, RAG is an example of grounding that comes with the input. But also there's output validation. So, for example, if you generate citations, or if you generate any particular, let's say, rule-based boilerplate that you add. So for healthcare, let's think if you want to generate some boilerplate of advising them to check with their physician based off certain rules for the question I'm asking. This would be a place where you can test for that. And then 4 is testing with validation, grounding, and the UX UI. So if you are concerned that maybe there's something being misunderstood by your users, you can test here. This one is, depending on what you're looking to test, like you can test UI in a automated way. Testing UX is going to be a little more complicated to test. But if you're doing maybe focus testing on a sample of users, this would be where you do that. So right now, Pacific AI is built for testing tiers 1, 2, and 3. As I said, like 4 is sort of more of a traditional UX UI testing. So let's talk a little bit about where we're getting our data from in Pacific AI. So, like I said, it's a new field. Mostly they build data sets for tier 1, even though there are some things out there that like test data sets for testing dialogues or testing RAG. Those do exist. And Pacific AI combines data sets from a wide variety of sources. So from the research community. And one of the things we can do with length tests is we can take existing data sets and using the methodology within length tests, they can be perturbed in order to test different use cases. And we also create ours with subject matter experts. And not just creating our own data sets from scratch, we also take ones from the research community, we modify them and add them. There's a lot of work we're doing on creating the data sets because, if we want to make sure these systems are not just effective, but also safe and compliant with regulation. We need to make sure we have the appropriate data sets for the job. Currently, we have 21,000 instances, test instances across 36 data sets and more than 30 testing scenarios, and more are being added all the time. And each data set has a metric to it. So the way we make this sort of sensible to everything is every data set has its own metric. If it's not normalized to between 0 and 1, we will usually use some sort of modification to do that. So you modify the number that comes out, and then we do macro averaging. So if you have a test, we have a test like for data set A, data set B, and for testing testing social bias, let's say. We'll run each one for A and B, and then we'll just average those two. And that's how we're able to produce these combined metrics. We also have LLM as a judge is one of the ways that we do testing. That's sort of, I think, again, obviously it's new because it's from LLMs. And LLM as a judge is easy to do wrong, but when you do it right, it's really powerful because it lets us test things that previously in the NLP space were not really easily testable. So, for example, if anyone here has like done testing for automatic summarization in the past before LLMs, that sort of you were comparing textual similarity between the two, the reference text and the summary, and that's reasonable, but it doesn't necessarily give you an accurate picture of how similar the summary is to the reference text that you're summarizing from, especially if you're looking to do a focused summarization. So let's say we have an inpatient record, which can be very large, and you want to produce a summarization of some particular clinical tests that were done. Well, if you look at the textual distribution of the reference text, that's going to look very different than a summary made from, maybe like 10% of the document. And so you have sort of an artificially lowered score, or you have to modify the original document. It's very difficult to get that notion. So LLM as a judge, though, can do this if you tune your judge well, can do this very effectively. So let's talk some more about the red teaming. So these adversarial tests, they're built to try and then poke at what might be weak spots. It might be spots where a system could be out of compliance or risk the users. So we have a team of physicians that work on creating these so that they're realistic. That's actually another important point to bring up, is that a lot of the existing open data sets out there, they're good. They're better than just like spot checking your system, but they often will have unrealistic data. And if you're doing tier 1 testing, maybe that's not so bad, because you're just like looking at, maybe you're looking at log probabilities or something like really down in the details. But if you're looking to test your overall system, they're not great, because it's a very different distribution which you're going to see realistically. So these physicians, they can make the realistic looking data. And we evaluate it using LLM as a judge with 3 different strategies. So the first one is the general criteria testing. So this is where we give the judge LLM sort of what's the behind the scenes of this test. Like what are you supposed to look for? What's the trick that we're trying to do to elicit the response we don't want? And we have a set list of criteria, such as like making sure that the LLM's output is clear. So we have things like 8 or 9 different criteria that the LLM checks against, given the input, the answer, and this sort of behind the scenes information. The second strategy is the must avoid testing. So the judge LLM is given a list of specific things that the answer should not have. And each one of these is created by the subject matter experts, the physicians. And unlike the general testing, the criteria is given individually for each instance with these. So this is, it is a considerable amount of work, but it gives us good detailed information about what's going wrong or what's going right with the system. And must do testing. So this is saying what things must be in the answer. So the judge LLM is given these specific aspects that it's looking for. Again, just like with the previous strategy, each one is done by a subject matter expert. And the LLM will give a pass or fail for each criteria. So now that we have some basic understanding of what red team testing is doing, so we're getting these physician-made questions and these criteria for judging them, and then we've tested some popular models out there. Now, granted, this is just tier 1 testing, and what we see here is that a lot of the models do pretty well, but if you consider the things we're testing, so we're testing social bias, we're testing cognitive bias, and we're testing other sort of like clarity and accuracy metrics around medical assistance. For some of these, these might be good scores, but let's say it looks like Gemini seems to be doing poorly here. I would argue that Gemini might fall below what maybe someone feels safe of just implementing. So they may want to look at one of the others, but maybe GPT-4o, for example, at 0.962, that might be not good enough considering the sensitivity of the things we're testing. So here it looks like Claude Opus seems to be doing the best. So with this, you can test your models, you can test your systems as well. And not just with red teaming, but with all the different data sets we have, you can get an idea that your system is working, is compliant. There's of course a lot more to like the actual regulatory and like legal aspects to this. But I encourage anyone who's interested in getting confident in their system to go ahead and check us out and see what you think. But yeah, I'm gonna hand it back to Alin now. Thank you.
Okay, and what I want to cover is like the security and the vulnerability of the platform and how this is covered by Pacific AI. So this slide will cover like all the key aspects of having like a secure and compliance like platform with medical integration of data sets and clinicians. So basically we have like this component like security testing and vulnerability management. So this is like a regular scanning dependency. So to make sure that no vulnerability is added into the system. We are taking care of data privacy and protection. So data it's encrypted and it's stored into a way in them it's also secure for the test workflow. So nothing is exposed outside the platform. Everything is stored in the internal VPC. So we have the access control, like low role-based access control with multi-factor authentication, fine-grained permission for different groups users for the test runs and how to access this part. Metrics, performance, fairness, and robustness. This is standardized version metrics. So with thresholds and also alerting that can be exposed on the platform, with that are coming also with audit and logging on different aspects, plus all the regulatory compliance. So this controls ensures in a way that Pacific AI evaluation workflows are secure, privacy preserving, and also auditable. So this something like provide regulators, clinicians, and also customers in a way as evidence of safety, fairness, and operational for their system. And now let's move to a demo. And I will present the UI interface that we built internally in Pacific AI. And in this case, how the application works is like, all the time we are registering, starting with registering a system. And what a system means is like, it's a dedicating testing scenario that it's based on a chai model that will create in the end a model card with details that can be exposed and saved and exposed to the end dashboard. So this one can be exported from here. So based on whatever it's registered here as summary, like pre-stage. So everything are like a default conditions that we maintain and we add here for the test case, and how important that is, and how the user wants to do that with the manager, and what the description of the system is, and what keywords it will use, last chain point, next chain point, and all this part. Then user can upload documents that are related to that. So whatever documentation and stuff it's related, this can be uploaded here and it will be stored and saved here. Then it's the model card that it's automatically generated based on the summary and all the information that the user has provided. But if the user wants to edit and make their sections as they wish, they can edit the sections as they want, and then the model card will be automatically generated and it can be exposed. We have also versioning exposed here, and all the information and also the key metrics and stuff will be exposed here in the document as soon as the test and stuff will run, and they will be collected. Okay, so what that means that we have here like an overall dashboard, summary, key performance and safety metrics, and then also the model card that I just exposed, and the most important part, and I will come then to the test suite and leaderboard. It's before starting any evaluation, any plans, in the settings, we will need to register the LLMs. So what I have here is like, I have here like two LLM providers registered. OpenAI, I'm using the GPT-4o mini, Azure OpenAI GPT-4o mini, only to expose like the difference and how they act and how they can be used. So right now, when we want to register an LLM, it's very easy. So we have the provider, OpenAI or Azure, and basically whenever we can select, we see that we have like popular configurations from OpenAI, and we can select, okay, we want to go with this one, and basically a lot of default parameters are already exposed here. Then we only have to provide the OpenAI key to validate, and basically the LLM endpoint, it's saved, stored, and it can be used against testing. So this is OpenAI, this is Azure, and the Azure again has exactly the popular configuration. And if we select something from here, it's automatically exposed, and we have only to come with the base URL, API version, and the API key. It will be stored into the AI eval management system, secure, and it will be used based on only on the ID. So the backend will only take care of using the IDs, and the API key will not be exposed to the evaluation plan, to the system. This is used through a secure way, through an internal provider that takes care of LLM storing mechanism, and take care of all these parameters and arguments into a unified way. Then we have the users and roles based on how they can execute, and then can see I am acting as an admin, as you can see here on the platform. Then we have the hub, in the hub space. In them we can come up with data sets. What I uploaded here, it's like a simple data sets for scenarios with simple questions, and the current version of the file and the header of the file that needs to be provided, it's like in a manner of a question, expected answer, or evaluation points, must do and must avoid. And this is treated on our backend by the judge model and by the model that is used here in the backend. And let's do a test. So right now we have configured LLM endpoints. We have also uploaded data sets, but this is only if we want to test against custom data set. But all the categories and subcategories have already like data sets associated in the backend to the scenarios. So right now here I have like 4 different scenarios. One scenario that I tested against 3 different categories, and as we can see here is like this one was run 1 second. So 3 categories: usefulness and efficacy, fairness and equity, safety and reliability. So and we have the scores for that test. This was run against, as we can see here, OpenAI GPT-4o Mini. The same was run against GPT-4o Mini, but from Azure and not from OpenAI. And what we can do is like we can select these test runs and run a comparison, and we can see that in some variations there are some difference based on the models that are used in terms of the scores, and these are the difference that can be done and can be obtained directly from this dashboard. Another aspect that I want to expose is like we will see here like we have here a dashboard that is based on the top category, but if we drilled down, we can see these are like subcategories of that given category, and we can see like the score that was done. In this case, we have like only the medical research and social biases that we have the score here. But if we run multiple categories, we will see like multiple updates on the others again. Okay, let me also show you like the OpenAI and the test run that I have done like with that 5 entries and then also with the 50 entries. So we can also compare different runs. So I had here one run with OpenAI in the same run, and then I have run it with Azure OpenAI, and we can compare and see that the data set had the difference. So with OpenAI, it's a score, the same data set, the same values, and with Azure OpenAI, it has a different score. So we can add as much models as we want and use all the models that are available from the provider, from other providers. So let's create a simple test suite. So we will select a category that we will want to test. So let's say that we want the cognitive biases. So this is like a category, and this has like these two categories that it will check. And let's pick also the medical assistance that will have like one category that it will test. We will select then the LLM that we want to test. Let's pick Azure, give it a name, test medical. Okay, and hit save. That means that the test run was saved here. And if we evaluate, that will start the evaluation, and in the backend we will see that basically that are 3 runs, one on each independent subcategory of the category. So these are from first category, that 2 subcategories, and then this one it's from the latest. And we see that it will we have a progress here, and it will complete. And after completion, we can see the results. So right now we need to wait for them to complete. So 2 of them are already done. Okay, let's until it will complete, I want to show you somehow like, yeah, here are like, yeah, all the categories that we support right now, and also the ones that requires GPU. They are mentioned here. So user can select whatever category he wants to test, and then yeah, the GPU cannot decide because, yeah, there is no GPU deployed in the backend, but everything else here can be selected, whatever user wants to implement. And basically then the test can be saved, and then they can be run. And if this one was run with GPT-4.1 mini, we can see here like, yeah, whatever was used for the model on evaluation. And here on the custom data set, we can see that, yeah, one of it was run with OpenAI and one with Azure. So this one was run with Azure OpenAI. We are waiting for it to complete. So this one, yeah, will take more because it has like a larger data set on the backend. And let's also mention about the leaderboard. In them we can see like, yeah, all the categories that we have run test against, and we can see exactly what each category has scored on different model by different providers. So this is like OpenAI, and this is like Azure OpenAI. So as a short description, yeah, it looks like, yeah, this one takes some while to complete. Let's as a short description, this one is like, yeah, a specialized testing environment that is designed for healthcare and not only environment system. And it can produce like an offer like model documentation, comprehensive testing, performance benchmarking, and also, let's say, team collaboration to uphold safety, fairness, and regulatory compliance. So thank you all, and I'm waiting questions.